Hello everybody, and welcome back to my card game tutorial series. Before I get into this video, I want to shout out my very first Patreon supporter. In all of my previous videos, I left a link in the description to my Patreon, and I never really promoted it. If anybody is interested in becoming a patron, there will be a link in the description. So let's get into it. In the last video, this is where we left off. We added all of the information for each card in the set into the game, and we also created code to drop cards onto the field. Now, we left off with some problems to where if you try to drop a card in the same position, it would just remove that card completely. So we're going to address that. So by the end of this video, this is what our program should look like. As you can see, we have our own deck. It's no longer Squirtle, Bulbasaur, and Charmander. We will set conditions that won't allow us to drop energy cards or trainer cards in field slots, only Pokemon. And then we'll also create a preview for each card. In the last video, I recommended going to the link I left in the description or following my Twitter, because I linked a Google document that had all of the card sprites we will need for our program. Now, what you will need to do if you haven't already is upload each one of those card sprites into the game. Now, the best way to do that as quick as possible is to use your shortcut key Alt-S, because that will create a sprite for you. You'll want to import your cards one by one. Then you would want to name it. And for each card, we're going to need two sprites, a big sprite and a small sprite. For the small sprites, we want to set them to a certain size. So what we're going to do is we're going to click this Resize Sprite button. In the Maintain Aspect Ratio, we're going to set our width equal to 76. That will automatically adjust the height to keep the same aspect ratio. Then hit Apply. We're going to want to justify it in the middle center, then lock it. So for each small sprite, I recommend using this format, SPR_Alakazam. And then for each big sprite, we want to do SPR_big_Alakazam. And we're going to do that for each card. So for the big sprites, what we're going to do is do SPR_, and for each word in between them, put an underscore. I'm going to paste code into the description of this video for a future script, so you want to make sure you use the same naming convention I use if you plan on copying that code over. But for the larger sprites, we want to set the height equal to 320, which will then automatically reset the width to be the appropriate size. Justify it, middle center, lock it, and then exit out. You want to do this for each card. So if you haven't done that yet, you will want to do this before moving forward. So if you have done that, what we want to do is reinitialize our sprite array. So this is the code that I will link in the description below. So if I paste that code in here, it will have every sprite that we just added. So the first one I added was the card back, because I want each sprite to correlate with its card number. Alakazam has a card number of 1, so this will be 0, this will be 1, because we're starting at 0. So then if you have your big card sprites also uploaded, we will create a new script that will mimic that. it'll be script underscore init big sprite array. And it will be exactly the same. So we're going to paste that one over again, but we're going to use the Control F command, and we're going to search for every instance that says sprite array, and we're going to change that to big sprite array. And we're going to hit this double or triple replace all check mark button, and it will go through each instance that has that and change it. So then we're also going to do that for anything that says SPR underscore, and we're going to change that to SPR underscore big underscore. So now we have the two scripts that will include every card sprite in the set. And we're going to want to remove this because we're going to keep the regular card sprite in the first position. So don't forget that. So now what we want to do is add those sprites to our objects. And the objects we want to add that to are our player object, our card object, and our field object. So each one of those objects should have these two scripts in them. So what we want to do now is make sure we have all of those cards in our game. So what we're going to do is we're going to reinitialize our deck to have each card in the set. So we're going to create a script called script deck all cards. We're going to want to initialize two local variables. We're going to set I is equal to 0 and j is equal to 1. And then we're going to create a for loop that says for I is equal to 0 and I is less than 102, because there's 102 cards in the deck, I++. So for each 102 positions of the deck, we are going to set that equal to a number. And that's going to be j++. Now, as you can see, j does not turn yellow. That's because I put a semicolon here instead of a comma. So now each position of the deck will have a unique card to it. And then we're going to set our deck count equal to I, and then return. So we want to remove the old deck initialization we had and replace it with script deck all cards. Now, one thing that I noticed in the last video I uploaded was in my shuffle script. We need to fix this before moving on. This wasn't an issue before because we never filled up our deck to be full. So now that it is, we will run into a problem. So what I need to do is in this random range is we have it set to be between 0 and deck count. Now, deck count equals 102. We have 102 cards in our deck, but since I takes up one of those positions, the 0 position is 1. So therefore, the 101th position is the 102nd card in our deck, because we have a deck of 102 cards now. So what I want to do is minus this by 1. So if we open up the random range script in the help tab, you'll see that it will choose a value between the two numbers you put in that script call, including the numbers you put in there, and that's what the problem is. So we need to change this from deck count to deck count -1. So now we won't have a problem. And we have an error right here, syntax error here, because I put I is less than 0 and that should say I is equal to 0. So let's fix that before we move on. So now we have this new deck initialization in our object player, and let's see how that changes our game. Now, if we press the up arrow key on our keyboard, it should expand our deck. And we can see all of the holographic cards that are in the set. But we can't see what's going out of the room. Later in this video, we will add code to allow us to sift through this deck. But we should be able to shuffle the deck if we press the left arrow key. So let's press that. As you can see, we're shuffling the cards in the deck, and we can see more cards than we previously could. But I want to make sure each sprite is in there. So let's create code to be able to sift through our deck. That code will be in our deck object. Now, the code I'm about to show you is very complex. What it's doing, or what it needs to do is when we select somewhere in this area, it needs to move all of these cards according to where we are dragging them. So this took me a lot to figure out this formula. I'll do my best to explain it, but I'm telling you now, just copy it over. If you don't understand it by the end of the video, just leave a comment down below and I'll do my best to further explain it after you've seen it, after you've written down the code, after you've seen it work, and then maybe I can better explain it so you can understand. So the code I used is if the player variable face up is asserted, which means we pressed the up arrow key, with player, because these variables we will be using are in the player object, so let's add those now because we haven't done that yet. And those variables are an X view variable that I'm going to set to 0, a Y view variable that I'm going to set to deck Y, and deck X2, which I will set equal to deck X. And one last condition that needs to be met in order to sift through the deck is that the mouse Y has to be in between the top of the card and the bottom of the card to sift through the deck. So that condition will look like this. So now we need to check that the mouse button is pressed. And we're going to use the script or the function mouse check button, and we want to check the left mouse button. So if that has been pressed, we want to record where that X coordinate value is, because we're going to move the deck along the X coordinate. That's going to be the distance between the new deck X2 position variable we created and the mouse button. Because the deck X2 variable is going to be the one that moves and drags the deck. So if the mouse button is still down, which means we're dragging and moving it, which means we're dragging it, we want to change that deck x2 variable to equal xView plus mouse x. Now, this will move the deck across the x-axis, but there are points where we don't want to move it past. So we don't want to move the top of the deck to the right of the deck. We want to move it all to the left. And then we don't want to move the last card too far away from the deck position. So we need to clip where this deck can move, or where the cards in the deck can move. So if the deck x2 variable is greater than or equal to deck x, we want to force that view to be less than deck x. So we're going to set deck x2 to equal deck x minus 1. And then if on the other end it's starting to become less than the deck position after all of the cards have been sifted through, we want to force it to stay there so that you're not moving all the cards in the deck somewhere else or too far off of the screen where you can't get to them or where you can't see them. So this is going to be a little bit more complicated. So just copy this over. So what this code is doing is it's going to account for every card in the deck, its width plus the buffer in between each card, and it's going to measure the distance of all of the cards you've sifted through, and if you've gotten to the last card in the deck, it won't let you keep moving because you've already flipped over every card in the deck. So then what we want to do is set the deck x2 to stay in that position where all the cards can be viewed and not let it move any further. So that code will look like this. So I'll let this stay on the screen for a little bit longer to make sure you have it all. So that's all of the step logic we need to do this. Now we need to draw the cards once the deck gets to a certain position, or the X view gets to a certain position, because once the X view gets bigger, it's going to start printing out the cards in the deck instead of just laying them all on the table. It's going to, once you move the X view, it'll start showing each card in the deck. So you'll see how that goes. So what we want to do is we want to keep this code, but we only want to use this code if the face-up value is not asserted. So if the face-up is 0, draw the deck regularly. If it's not, this is what we're going to do. For each card that hasn't been turned over yet, which means the X view hasn't gone an appropriate distance to print out that card, we want to print the card back, just like we did before. So that's what this for statement is going to do. Now, the next line of code will draw each card that has been dragged away from the deck. So for I is equal to deck count, and I is less than or equal to 0, I minus minus, because now we're going backwards. So I had an error there because I accidentally put a parenthesis here. So once I got rid of that, the error went away. But now this is all of the code we need in order to make this draw the deck the way we want it to. So now let's load the game and see how this works. So let's press the up arrow. Ooh, and we got an issue. So that's on our line 25 in the draw event. So that's here. So it's saying that we're out of the array. So let's see where that messed up. On line 25. So what happened is we set I equal to deck count. Deck count equals the number of cards we have in our deck, which is 102. But the array starts at 0, so it should actually be 101. So we need to set I equal to deck count minus 1. So let's hit the play button. Now if we press the up button, oh my god. So one thing I forgot to do was in the step event, we need to remove these values because we used that for testing purposes before, but now we're doing something different. So that is what made the cards go all the way to the left, even though we haven't moved the deck at all. So now if we press the up arrow, we can see that the topmost card is now shown, and only the topmost card. I accidentally hit the shuffle button, so let's restart that. Now if you see when I press the up button, the deck seems to get a lot bigger. That's because in our draw event, we're still accounting for only 60 cards because there's only allowed to be 60 cards in your deck. We put 102 just for the sake of troubleshooting. So that's why that's happening. If you're wondering, when we draw the deck, we're only accounting for only 60 cards. So we can change this to deck count so that all of the cards can always be drawn. It doesn't matter. So it just typically in Pokemon you have to have a 60 card deck, so we just put 60. So now we see we have this big deck with 102 cards. If we press the up arrow button, we now only see the topmost card of the deck, and it's not being shot across the screen. But now with the code we just created, we are able to drag every card in the deck over. And we can see all of our sprites that we added. And we can see that none of the sprites doubled up, are the wrong size, are out of order, and such things, and we can keep going all the way down. Now, one thing that I was really proud of myself for is if you see the deck pile is actually getting smaller the more we drag out of the deck. So I thought that was pretty cool. So by the time you get to the end of the deck, you don't see the deck anymore. And these are the conditions that we put in to not let the cards move too far away. That's what all of those conditions were for. So we had a condition that says you can't move this card too far to the left, and we have conditions that say you can't move it too far to the right. So now one thing I don't like is how big this deck looks. So what we want to do is now we want to change the deck X and Y buffers to be a little bit smaller so it will fit the screen a lot better. So that variable is in our object player at the top or the middle. So it's 0.4, so we're going to change that to 0.2. So with the 102 cards we have in our deck, it's going to make a difference, but it's still going to go off of the screen. But when we have a 60 card deck, it'll actually be flush with the wall of the room. So you see it's a lot smaller now, and it looks a lot more manageable, looks a little bit better. So congratulations, this was very hard for me to do. I'm glad to share it with you guys. I hope this is helpful. We still have a lot more to do, but I want you to understand that this was very hard and it's very tough. It was very tough to figure out how to do this exactly. So I'm glad I can share it with you all. Now, let's start the game, and what we want to do is not be able to drop trainer cards or energy cards on the field, and we want to stop losing cards every time we set them in a position where a card already exists. So let's do that now. So that will be in our object card. What we want to do in our left released button is add a condition here at the top that says if the player field is equal to 0, which means there's no cards there, allow the player to drop a card there. So that will allow us to not drop a card in a field slot that already has a card there. But we also only want to do it if the card that we have in our hand is a Pokemon. Now, this condition by itself will do what we need it to do. So, two things. I used self because we have a card number local variable. We want to use the card number in this object, which is why I put self before here. And we also don't have the script that lets us determine if the card we have is actually a Pokemon. So let's add that script. We're going to call it script is Pokemon. We're going to take in a variable. So we're going to create a local variable called card number is equal to argument 0 minus 1. Now, the card number actually is argument 0, but we're decrementing it for a reason. So let's, just for this example, let's not decrement it here. We're going to take in the card number as argument 0. Now, we have all of those, we have the two arrays we created in the last video, the strings array and the card number array. So what we want to do is we want to actually pull something from those arrays to determine if this card is actually a Pokemon or not. So let's look at our arrays that we initialized. This is Alakazam. So what we need to do is be able to look at this for Alakazam and figure out what information can tell us, is this a Pokemon? And the way I did that is instead of looking at a Pokemon, I looked at the energy cards and I looked at the trainer cards. So if you look at the energy cards, this is the information we have. Mostly it's nothing, but we see we have grass energy, and in the second position of the strings, we called it energy just like we did with every other energy card. It's even that double energy card, even the double colorless energy card. And then for trainer cards, in that position we called it trainer. Now this is the type. For Pokemon, in the type position, we didn't name it energy, Pokemon, or trainer. We gave it the type it had: lightning, grass, water, fire. So this is the one we're going to use. So what our condition is going to say is, if strings, we're going to use the card number, but we're going to actually subtract it by 1, because in these string arrays, if we multiplied it by card number, we would actually overshoot. So say if we had Voltorb and we multiplied it by the Voltorb card number, it would actually go to Vulpix. So what we want to do is we want to multiply it by the card number under it, so then it'll get us to this position, and then we can just add the number we need. So since we're going to be at the Tangela card number, using strings, this is going to be the first position that we get to, but we want this one. So in our string array, we're going to say card number -1. We're going to multiply that value by 10, because there's 10 string variables for each Pokemon. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we want the second string variable. Remember, 0 is the first position, 1 is the second position. So we're going to multiply that by, so we're going to add 1 to that value. So that will get us to that position. So if that is equal to trainer, or that position is equal to energy, we know that's not a Pokemon. That's the only condition that would make it not a Pokemon. So we're going to return 0 because it's not true. Otherwise, return 1 because therefore it is a Pokemon. So now that we have that script, if we go back to our object card, wherever it is, we'll see that that script is now orange. So now if we load the game, we should see if we are able to drop a card onto the field that is an energy card or a trainer card. So we have an energy card here. You see how it doesn't allow us to drop that energy card or this trainer card? Now let's try to get a Pokemon. So we don't have our deck shuffled yet, so I'm going to shuffle it now. I restarted the game and I hit the left arrow key button on my keyboard to shuffle the deck. Now let's start the game. So we have some Pokemon and we have a trainer card. I can't set the trainer card, but I can set a Pokemon. As you can see, I shouldn't be able to set this card here. That's because we never set the field variable to equal the card number before. We just created the object. So the next line we want to create is player field I is equal to self card num. Now, before we created the object that goes onto the field, but we never set the field variable to equal anything but 0. So now that this is here, this condition will kick in and not allow us to drop a second card in that same position. So let's shuffle the deck and press the enter button. Let's drop a Pokemon in one position and try to drop another Pokemon in the same position. As you can see, it doesn't allow me now. It doesn't allow me to add an energy, doesn't allow me to add a trainer. Can't put an energy here or a trainer here, but I can put a Pokemon here and here. So now, before we move on, let's shuffle the deck before we even get into the game, because with any card game, your deck should always be shuffled. So let's go back to Object Player. And right after the script deck all cards, let's put script shuffle deck. And instead of having all of the cards in the deck, let's create our own deck and get rid of this. So we're going to create a new script. Script deck 1 initialize. So I'm going to paste this one over. This is a deck I created, and I will show you in the game. So if you want to copy this code over, I'll also paste that in the description. If you want to make your own deck, feel free to. If you need help creating a deck, leave a comment below. I'll be glad to help. But since we have that now, let's play the deck. Or since we have that now, let's play the game and see what the deck looks like. So if I press the up button, I can now sift through the deck. As you can see, it's shuffled because we add that script call after we initialized the deck. But you can see that this deck is primarily based around Squirtle and Poliwag. This deck is very, very overpowered when it comes to the original base set. This is a deck I play with. I currently have a physical copy of this deck, and it's very fun. So hopefully we get to a point in this series where we can connect our games with each other and play with each other. You can make your own deck, I can make my own deck, and we can play with each other. But this video is getting long. I know I promised in the last video that these videos will be a lot shorter, but I get a little overzealous and I overpromise, and I don't realize that it's getting too long until I start making the video. So let's wrap this up by creating a preview of the cards we drew using the big card sprites we added. So let's do this really quickly. We're going to go to our object card, and in our draw event, if it's selected, we're going to say draw sprite, big sprite array, card num, -1, and we want this in the center of the room. I believe. So let's see what that looks like. Let's start our game. Let's push this button down. So when I click this card, I get a preview in the center of the game. Now, one thing is I don't want this to be on the screen anytime I'm holding it. I only want it to be there if I have it down here in my hand. When I decide to play it, I no longer want to see it anymore. So I'm going to add another condition right here that says if the mouse position is greater than the Y position of the card. And what I mean by Y position of the card is the initial Y position of the card, then draw it. So let's see what that looks like. So the Y position of the card is this area right here. This line right here. So if I hold it down and it's higher than that because it starts from 0 and then goes down. So if I hold this card and drag it down, I can then see the card. So now when I'm here, I no longer see it. But now let's make a preview for the card that's on the field. So that's in our object field card. We're going to add event. We're going to add a draw event. We're going to say draw self if selected is equal to true. draw sprite. Just like we did in the card object. But now we need to create events that turn selected into true. So we're going to use a left pressed, which means if the card object has been clicked on, we're going to set selected equal to true. If it's been released, which means you're no longer pressing it down, selected is equal to false. And if the mouse moves out of the card sprite, selected is equal to false. So this is where I'd like to end the video. What we're going to do, let's see that this preview is actually being shown. Let's drop this card. If we click on it, we can see the preview. If we move out of it, we can no longer see the preview, or if we release the mouse button, the preview also disappears. And that should happen for whatever card is on the field. So again, I got a little overzealous with this video. I thought I try to fit as much as I can. If you prefer longer videos, let me know in the comments below. If you want shorter ones, I could definitely do one thing at a time and maybe produce 2 or 3 videos a week instead of one long video a week. Again, I'd like to shout out my first Patreon supporter. If you guys would also like to support me in creating my own card game, check out my Patreon linked in the description below. Follow me on Twitter. I usually tweet out things that can help you in your program. Again, if you need any clarification on what we've covered in this video, ask me in the comments below. If you haven't subscribed, subscribe, and until next time.